Okay, so as we saw right before we ended the last video, that you guys already have kind of an instinctual understanding of some of the simple inverses. And I wanted to give you some examples. Oops, there they are. And you know what? I thought of another one in between videos, so I'm sorry about this, but I just wanted to remind you of there's one other one that is simple that you guys do know. If k of x is equal to x squared, then k inverse is equal to x to the 1/2, remember? Because that's how we get rid of powers like that. We can think of it like a square root, but honestly, I don't want to just do 2 because then people are like, oh, it's square root. Yeah, I know, but what if it was 7? Then it'd be 1/7, right? We covered that in chapter 4. So adding and subtracting are inverses, multiplying, dividing, powers, and then the fraction power. But if you involve more than one thing, like what if it was 2x squared plus 5, that's really tricky. What we're going to do is we're only going to work with linear ones. So we're going to work with like mx plus b. But if I start adding powers in on top of all that, it gets even worse. So there's a lot of more complicated examples. We're going to do linear ones. That's the name of this section, was inverses of linear models. So that's what we're going to do. Now here's our process. So we're going to find the inverse of a model this way. And these are for models, but it's the same idea when it isn't with a model. You're going to replace f of t with, I hate that he puts a letter in here because it's not really P, it's whatever letter you've got. Like in our example, when you look here, it's going to be the letter R because that's the letter we have. And then you're going to solve for T and replace T with F inverse. Okay, so let me do this by hand here. So R is equal to, oh, you know what? I need you to make a table. Hold on one sec. There we go. I just wanted to be able to label my steps here. So step 1 is you write it with letter R. Now I know this particular problem was kind of lame because it kind of have it as R to begin with. But if it had been f of t, and now you see why I didn't do it that way because it knocked it down to another page. But if it had been f of t, then you just replace it with the letter R in our example, or P, or whatever. You're just putting in a simpler letter. That's all step 1 is just simplifying, right, with a simpler letter. All right, then step 2. This is where the algebra part is. You need to solve this equation for t. Now currently it is solved for r. That's what it means in math class when they say solve for a variable. It means you get the variable, then the equal sign, and then all the rest of the stuff. Okay, so currently this is solved for r because it's r equals lots of stuff. I want it to be t equals. So you need to get r by itself. Now the first thing you might notice is you need to subtract 6.38 from both sides. So I'm going to do it to the left-hand side, and I'm going to do it to the right-hand side over here. Subtract 6.38. Now I do that because that'll cause these to disappear, because if you have 6.38, you take away 6.38, you get nothing. Now over on the left-hand side, these are not like terms. One's got a variable, one doesn't. So you just have to write them. R minus 6.38 equals 0.63t. There it is, right? They're not like terms, you're stuck. All right, now you need to divide because you need to get t by itself. So 0.63, and you're doing that because you want to be able to divide this away. There's not all of it, just the 0.63 part. But of course, if you do it to the left-hand side, you have to do it to the right-hand side. So 0.63 over here. All right. Now technically you've solved this for t, and I'm going to flip it just to make it easier to work with. But t is equal to this. But you're not done. And here's why. This is terrible form. We never in math leave decimals inside a fraction like this. This is just brutal. So we need to come up with or let me put it this way, we want to turn them into unit fractions. We want the denominator to be 1. So what I'm going to do is I'm going to break it up. There's actually 2 parts here. There's the r part and the 6.38 part. And I want both parts to be divided by 0.63. Now, what number is in front of this r here? Did you answer 1? You should have, because there's a 1 right there. When you don't see a number or a coefficient, that means it's a coefficient of 1. If it was 0, then there wouldn't be anything at all. It would just be nothing, right? but there's an R, which must mean it's a 1. So what I'm going to do is I'm going to break this up. 1 over 0.63, that's times R, right? There's the R part, minus 6.38 divided by 0.63. All right, and again, still no good to us. We do not want our denominators to be 0.63. We want our denominators to be 1. We want this to be unit fractions. In other words, you don't want decimals inside of your fraction. You just want decimals. So you take a calculator and make it find what 1 divided by 0.63 is. There you go. 1.58, oops, what was that? 587. R, because that's your variable, minus, and then 6.38 divided by 0.63, 10.127. There we go. Oops, I better make it its own list, to be honest. Right there. That's what we were shooting for. That's the end of step 2. Cool. Now, step 2 is where a lot of the real work is, to be honest with you. Step 3 is really simple. Step 3 just says replace t, see where the t is, with f inverse of, now again, he uses the letter p, but it doesn't have to be p, and it's not in our case. Let me get it. It's r. That's our variable. So when you look over at the big old mess, what's the variable you see in there? R, which means what you've created is a function of r. So you need to have that be your variable. So the top box on the page says p, but it's just saying that for generic reasons, right? It's saying, you know, hey, if it's p equals f of t, well, yours wasn't. Yours was r equals f of t, right? And therefore, you've got to use r on your problem. If they said A for Alana, then you'd use A. You'd use whatever letter they give you. But this is your final result right there. All right, for letter B now, let's find f of 15. And then you'll notice letter C has f inverse of 15. So be very careful for these problems. You want to pay close attention to what you're actually being asked to find. So for letter B, that's the regular function f, right? So I want to take 15 and I want to put it into the original function, right? So let's see, it was 0.63. So f of 15 is equal to 0.63 times 15 plus 6.38, right? And let me just also remind you real quick that it was f of t is equal to r, right? So that means that your independent variable was time and your r is your rate. Oh, and what is this? This is approximately 15.83. I just get that with a calculator. All right, now the kicker is, what does it mean? Well, that's where that f of t equals r thing comes in handy. So you say, okay, look, I put in 15 for t, so that's time. So you'd say in 15 years, so, oh, wait, 15 years from where? 2000 was our starter year, so I guess I should just say 2015. So in 2015, about 15.83, this is passengers that are bumped. Number of passengers, that's a typo, bumped, per 100,000 passengers. Because it's not like they bumped just 15 passengers, they're bumping 15.83 passengers per 100,000. And you know, if 100,000 people fly a day, that means about 15 to 16 people are getting bumped every day. So in 2015, about 15.83 passengers per 100,000 should expect to be bumped by the airline. Expect to be bumped by the airlines. And of course, like with most things, it's as long as you're making a full sentence that explains both the 2015 and the 15.83 and has appropriate units, you're good. So you could say, by 2015, about, we should expect bumping rates to increase to a level of 15.83 passengers per 100,000, something like that. That's fine. All right, now the inverse function works backwards. See, inverse takes, if I could write it out, takes R and gives you back T. That's the whole thing about inverses. Remember, the tables flip-flop. What was independent becomes dependent and vice versa. Okay, so what's that going to mean for us? Well, it means I'm going to take 15, and instead of putting it into the original function I was given in the problem, I'm going to put it in, here, I'm going to make a note of myself right here. We put it into the original, right? But here, we're going to put it into the new one that we made, the inverse one, which is right there. So I'm going to say, oopsie, sorry about that. There it is. All right, so this is 1.587 times 15 minus 10.127. Oops, lost my parentheses. Minus 10.127. Oh, let's see, which I got to be about 13.68. Okay, now remember, this is going backwards, so it's saying the bumping rate of passengers, the passenger bumping rate, or something like that. The airline, I guess I should say airline passenger bumping rate will be 15 per 100,000 passengers in about, or here, it's in 2013, but it's late, so by 2014, if I round it up. See the difference? So this one up here took 15 for years and gave you rate. The inverse takes 15 for the rate and gives you back the years. They're inverses of each other.